nobody touch anything.
All right.
All right. So this is Maya from San Jose State University. She has, as you should know, done some work with AI and music, which to me is very interesting because now we can actually use, we can forget, singers and songwriters and have machines generate our entertainment instead, which is ideal for me. So, Maya, you can take it away, talk about yourself if you want, and you are most welcome to sit down. You don't really have to stand if you don't want to.
Okay. Well, thanks so much, Alvin. It's really nice to be here. It's my first time visiting Ericsson. I actually moved to the area around July, so I'm fairly new here.
Welcome to the valley.
Thank you. It's a lot more exciting here than my previous place in Florida. Okay, so I'm going to tell you today about my favorite project. I actually spent most of my academic life looking at theoretical foundations of clustering, and then did a big 180 once I discovered this line of research. So I was studying computer science, looking at theoretical foundations of clustering, and towards the end of my PhD, started taking voice lessons, which I never thought would have any benefit for my primary career. As part of my singing life, I started singing semi-professionally, and I really wanted to make my own original music, which turned out to be notoriously difficult. Because to make one song independently, you have to know how to sing, you have to compose the music, produce the music, make up the lyrics. It's really a lot more multifaceted than I originally imagined. And I actually spent time trying to learn all of these individual components, which are repeated on this figure. But it was really taking too much time. It was looking as if it's unrealistic. But then then I attended a workshop in San Diego. It's called ITA, Information Theory and Applications. And there was a small panel there on computational creativity. Any of you ever heard of computational creativity? Oh, well, one person actually heard about it. I didn't hear about it till that point. There was somebody, Mark Riddell was talking about his work on having a computer that makes up stories. Then there was another person talking about algorithmic music composition. And Harold Cohen showed his work on an automated painter called Aaron. And I was just shocked and amazed. And I stuck around and walked them to their hotel for about an hour because I wanted to learn more about this. And ended up attending the International Conference on Computational Creativity, even though I had no papers there. Was introduced to this idea of a computer being a collaborator, which is really a new perspective for me. I always thought of a computer as a tool. And almost the moment somebody said this idea of a computer as a collaborator, I thought, great, okay, how about it collaborate with me on creating a song? And that's really how it all started. So the slides are non-technical. I don't like overwhelming slides with formulas and other terrifying things. But because you're a technical group, any details that I neglect to mention, please just ask. Okay, so this led to Alicia, which was developed by myself, David, and Chris. And ever since I put up the paper on ArcZiv, media outlets started getting in touch with me, which was in stark contrast to what happens when you publish theoretical clustering. This was this really fun surprise. Here I was doing something that I thought was incredibly fun. Still slightly amazed I'm getting paid to do it. And people care, so it's wonderful. So Alicia is completely data-driven. There's quite a bit of work within, let me kind of illustrate in what sense the work is original. Algorithmic composition is a pretty old field. You had musicians and computer science dabbling in it for decades now. But basically without words. Almost the entire literature is music by itself. And then of course you have a lot of natural language processing by itself, but it hasn't really been bridged. There's a small number of papers that do look at creating songs, but they're all pretty simple expert systems, where essentially somebody tries to encode one style of making songs. And those papers are really more from a computer science point of view, a computer scientist dabbling in this domain rather than an attempt to create serious music. And so we wanted to, because as a musician, I wanted to create songs that I'd be comfortable performing. That was my goal as a singer. And as a computer scientist, I wanted it to be data-driven. So I didn't want to make an expert system that would encode my way of how to write songs, partially because I didn't really know how to do it, and partially because from a computer science point of view, it's not as exciting too. So this is trained on about 30 songs. So kind of a small data problem. Of course, it could be expanded to large data once, even when the data becomes available.
So you say that input is only 30 songs?
It's only about 30 songs, yeah. And that's because
both the scores and the lyric together.
Yes, exactly. Okay, so the way the input looks is you have two parts to the score. You have exactly the natural language and the melody line to which you sing it. And we got rid of everything else. So no piano accompaniment, none of that information. Just those two. And what we're trying to do is understand the relationship. We're not trying to figure out how to write music independently or lyrics independently. We're trying to learn the relationship between the two. Yeah.
So did the music include the chord changes?
Not in this case, no. But that's, we're working on this right now. I actually, a couple of my students just managed to do something that creates chords given a melody, but I really would like to connect the chords back to the natural language as well. Because a lot of the mood comes out of the chords, and it's ideally present in the lyrics as well, so I'd like to make that connection more fully. Okay, so the model we use are random forests, largely because it's a small data set. You can't really throw neural nets at that. Of course, features are very important when using random forests. And because we're trying to understand the relationship between music and natural language, we have both musical features and text-based features. So the musical features are, you have some global information, like the key and time signature, but most important is the local information. So at every point, you're trying to predict the next note. So you already have the words, you have the complete lyrics, and you're trying to figure out what the next note is, and of course the system is going to make a prediction, and we're going to agree with it, and as such end up generating the whole melody. So the local information, such as the previous 5 notes, their pitch, their duration, are very important features. They come out to be some of the strongest features, which perhaps is not surprising. And then text-based features have things like stress. So, for example, in the word Maya, you don't want it to be Maya. But if somebody writes music for, on top of that lyric, if they make the second note very long or higher in pitch than the first one, then you'd be forced to sing it as Maya instead of Maya. Right? So we have to provide these kind of features that would let a system learn that this is important. And then other text-based features include stuff like word rarity. So how common a word is in the English language in general. And for the most part, as we learn through our system, rare words tend to be emphasized musically. If anything, at one point a musician was using the system and he wanted to de-emphasize a word that was rare, and it was hard to find a melody that Alicia created that would do that. So we ended up learning a lot about the way songs are written through the system, which was an interesting surprise. We're also adding some sentiment analysis right now, so whether a word is positive or negative. We're adding parts of speech, which I think is going to make a very big difference, because you don't want words like and articles and other not very important parts of speech to be emphasized. Okay, so we did some model accuracy. Does this make sense, by the way?
Yes.
Okay. So there are 3 models currently. We've experimented with different ways of modeling songs. This one seems to work pretty well. So that's a rhythm model, which predicts the next note duration. That's a melody model, which predicts the pitch of that next note. And that's the octave predicting the octave of placement of the next note. Now, to interpret these numbers, it kind of takes a moment. These models are not created equal, in large part because there's a different number of choices. It's not surprising that octave does so well, because realistically there's only about 3 octaves. There's only about 3 options at each time. And most often the octave doesn't change from note to note. So it's not very surprising that we're able to predict this well.
I'm actually surprised not higher.
Yeah. Perhaps it could do much better. That's right. So I do think there's room for improvement with the octave model. Then with the rhythm model, again, it looks like there's quite a few choices, but certain choices are rare. Like dotted notes are not very common in our corpus. So for that, maybe about 5 reasonable choices. Yeah.
So what's the input format for the sounds?
So it's all scores. So music XML format. Did that answer your question? Okay. And then so you train your model on these music XML files, but then when you want to use it, you provide the lyrics, and it makes up melodies for them. Actually, one sentence at a time. Yeah.
And these scores are based on the 30 songs that you have.
Yeah. So we split it up, right? I was trying on 75% and then tested on 25.
Right. So what's the how do you select those 30 songs? Are they pop music? Or?
Yeah, they're more on their pop songs. Good question. Yeah, we did try some Puccini music, and I'll show you that as well.
But what's the reason for such a small data set?
Oh, it was just difficult to find. Very simple. Yeah, we had to make it.
You have to make it.
We
Oh, these
entered it.
are original, the music you.
Oh, the music is not original, but we had to input it because we needed it in music XML format.
Yeah, we generate that.
Right.
Yeah, and it's there's a lot of data out there with just music that's already put in a good format, which kind of reflects what the literature focuses on. But as far as music with lyrics, accurately labeled with the lyrics and music sheet score, it was notoriously difficult to find. We actually ended up entering it. Yeah.
Here's the, are you aware of Lily Pond? It's a music notation, and it's text-based. It's not XML, but it's text-based, and it would be relatively easy to do XML wrapping on it. But there's a large body of music that's encoded as Lily Pond.
And you think they might have some that have lyrics?
It's actually
Yeah.
been proposed as it's a typesetting environment for music.
Okay.
It's very powerful because the music is textually represented. It's very much like LaTeX or TeX.
Right.
Oh, I'd love to have a look. That sounds
Yeah.
great. And especially if they end up having some more data.
And it's
for us.
open source for the
Lily Pond.
application. Yeah,
Lily Pond.
Oh, Lily Pond.
Yeah.
Oh, that's right. Yeah. Okay, great. Thank you. Yeah, getting more data would be so helpful here. For sure. And then the melody looks like the weakest model, but it has a lot of choices. You consider about 13 choices. And also, it's important to take into consideration here that music prediction is not perfect because at each point there are multiple options. There are multiple reasonable options for the next note. And this is measured in a very strict sense in that each time that you don't get a note perfectly correctly, that contributes to your error rate. And I like this strict measure because I think it's more accurate.
So what kind of predictor? Is it the armor or is it the spectrum based? What kind of?
Oh, it's a tree-based model.
Oh,
It's random forests, yeah. Yeah. All 3 models are all random forests.
Also seems to me that since music scores are so, the number of alphabets are so limited, it should be possible to take a score and do optical character recognition on them very easily and convert it to textual format.
Yeah, no, there is actually something that tries to do it. It just does it really terribly. Yeah, but that would be, of course, that would be the best way to solve the problem. To first solve this problem and then create an enormous data set like that. That'd be fantastic.
Because there is a huge body of music scores available on IMSL.
Well, as far as getting the actual document,
Yeah.
that's millions of files. That's right. So if there was a way to effectively, reliably convert them to either XML or some other useful format, that would create an enormous data set. So the way that the program looks from the user's point of view, and we really haven't focused on making a super fancy user interface at this point, but fundamentally the user types in a sentence of natural language and can get as many options for how to set that sentence to music as the user wants. And then the user then selects which one of these melodies for that sentence fits, they like it for whatever reason, and then strings together the melody by running the system multiple times for each sentence. So it's not entirely independent. We could in principle let it be entirely independent, but at this point, it doesn't have that global structure. That's one problem you have with algorithmic composition in general. It it's harder to get global structure, even though you can get nice local structures. So at this point, we're allowing the user for stringing it together into a meaningful musical piece. And that, of course, makes for natural future work to figure out different ways to let a computer figure out the global structure. Ideally, without turning it into an expert system. So that's a temptation here. Oh, this, by the way, is Joshua Palki. I feel very lucky to have a chance to work with him. He's a music professor at University of California, Long Beach, CSU Long Beach. And it's been very interesting getting feedback from musicians on this work. Musicians are by far the most picky when it comes to this work. They have a lot of, first of all, some emotional responses, which are interesting. Sometimes, no, not him, Josh has been wonderful, but I've tried showing it to other musicians, which is just fundamentally against the whole concept. Which is always interesting.
When even musicians' jobs are going to be automated, then, you know.
I think a part of their concern is coming from a legitimate place. I mean, even if I want to use this primarily as something to help musicians, there's nothing that prevents this line of research to evolve into something that tries to replace musicians. I hope that this is not anything that's going to happen soon. If you look at kind of the parallel in the world of visual art, there are some very good automated artists. So Aaron is one example with Harold Cohen's work. And then there is also something called the Painting Fool that creates beautiful work that's displayed in galleries and has been commissioned for tens of thousands of dollars, if not more. But it's just one artist. Each one of these is just one artist. It doesn't seem to generalize and replace the artists in general. So maybe there is some hope.
Also, if your goal is as a collaborator, then I would see it more as a producer. In that I'm playing this song and my producer would say, why don't you try emphasizing this chord, this note, or play it a little bit different. I mean, the way I see this would be in that sense, you know, why don't you try doing it a little bit different?
That's right, and I like this idea. I actually really like the producer analogy here. Yeah, ideally, from my perspective, I like the idea of helping musicians and also helping amateurs who, you know, are not musicians in the full sense, and so they need the help more than others. Joshua actually, he's a professional musician, he's a music professor, but he's more of an arranger. He directs choirs and he likes to arrange music. And he told me that actually coming up with melodies is something that he neither likes nor specializes in. And so Alicia helps fill in something that he doesn't really want to do, which is perfect. Okay. So we added a few co-creative functionality features. So features that are especially designed to support this co-creative process. So in particular, if the user finds a melody that they like, but they're not entirely sure about it, they could ask for similar melodies. So that's one feature. And then another one lets them say, I like the pitches that you selected, but not the rhythms. Please give me alternate rhythms. And then a parallel one if the user likes the rhythms, but not the pitches. So that had actually been very helpful to the musicians. Originally, I imagined this type of system being used in the electronic music domain. I dabbed a little bit into electronic music, and I noticed that it's almost all remaking existing work.
That's James.
Yeah. You guys are any of you familiar with that genre?
I represent him.
Yeah, and in a way, my brother does a lot of electronic music, and in a way, they're proud of it. They like it. They're proud of remaking works in various creative ways, and I do think that there's a lot of value in that. But I really think, at least kind of generalizing my own experience, the part of the reason that there's so much emphasis on remaking existing music is because there are good tools for that. Right? We have Logic, GarageBand, Ableton, and it's really not that hard to use. Producing music is surprisingly simple nowadays. Whereas composition, there isn't anything that helps a lot with that, especially once you want songs with natural language. And so I think if something like that was available, we would see a change in the electronic music domain. And so it was a fun surprise for me that from Josh Palti, the music professor, that there is utility for that kind of systems in the professional music arena, even for classical music. Yeah. So I'm going to show you a song after all this talking. Any more technical questions before we change gears a little bit?
How much machine power do you need to to compose these kind of?
Oh, this runs on my little
Laptop?
my little light laptop. Yeah, not very much at all.
And this is what programming language do you use?
Oh, it's in Python. We had it in Python and R at first, and now we're writing the whole thing in Python, making it a little bit faster. All right, well, you can ask me more questions as they come up. Okay, so you guys familiar with Emily Dickinson?
Yes.
Yeah, so she's this famous poet, writes really interesting poetry, very interesting combinations of words, and she inspired many musicians to set her words to music. And so we thought, well, why don't we let Alicia give it a go? So this song, which I'll actually sing for you, if that's all right. Make it fun. Prove that I have musical training. Okay. So the melody is by Alicia. So the individual lines are by Alicia. They were put together and selected by Josh Potty, the music professor. I'm going to sing it. My brother, Ron Ackerman, produced it, and the lyrics are by Dickinson. All right. So here are the lyrics, so you can see them as well. And I'll sing it. This music. It's a little bit disorienting. No, but it's great. I'm very happy about it. All right, so one thing that's very important in computational creativity is this idea of evaluation. In fact, the International Conference on Computational Creativity does not accept papers unless they have evaluation in it. They're very strict about it. And so we added evaluation. So this makes Alicia become its own critic. This kind of ties back to, Alvin suggested this. We ideally would want a system to be able to tell you, well, try something different here, which means that it would have some idea of how good different melodies are, right? And so to make Alicia its own critic, we made a function that balances how much the model likes a particular musical phrase with its entropy. So this first part kind of reminds me of having arguments with my husband and saying things that I was unlikely to say. So once in a while, Alicia would produce a melody that it itself was not likely to produce. Right? Because we generated one. There's always some chance of picking a low probability of that. And so melodies are better if Alicia was, first of all, more likely to generate them. That way they at least represent the model more accurately. Now, because we trained it on pop music has a lot of repeated notes. A lot of repeated notes. I had no idea how many, despite being a singer and singing a lot of songs across many different genres. I never noticed quite how common are these phrases where it's just the same note over and over again. And what's worse, sometimes the pitch is the same and the rhythm is the same. So it's literally the same eighth note repeating. As a co-creative system, it really serves no purpose to show the user, here is a melody with the same note over and over again. Nobody has trouble coming up with melodies like that. And so we punish melodies for being too repetitive. So we just look how much variety there is in this musical phrase, and if there's more variety, the score is better. And so we balance out the two scores. I mean, I'm sure there are many different ways to do this with a specific function that we picked, which represents these two.
Even if the notes are repetitive, you can apply different shaping. Different shaping, you can shape the same note differently.
Like in the way that you sing it?
Yeah.
That's true, and that's a good point. It kind of brings to mind a very new line of research which focuses on the performance aspect. There is some work, it's very, very new, there's hardly any work on this, but in particular there is work in Santa Cruz by a couple of researchers where they looked at, they made a system that plays piano pieces with expression. And then recently there was a paper on EverMuseArt or somebody kind of showing how to hold the bow when you're playing the viola or violin. So again, more things that are related to performance. And you're right, perhaps, a singer could give some variety to it. But from my musical experience, there's really only so much you can do with the same note over and over again. And not that these are necessarily terrible. I think sometimes in the middle of a song, they're not too bad. They kind of fit the mood. We just felt that because they're so common, the likelihood was very high, and so we had to punish them somewhat. And we don't eliminate them. Those sequences, the extremely repetitive ones and everything on the spectrum still get displayed. But we rank the melodies based on their quality. And so the ones that are more repetitive are still there, but typically towards the bottom.
I was going to say, Ralph, what you're saying, there's a song under, Johnny One Note. It's a
No.
jazz tune, and as the title implies, one note comprises probably 90% of the tune.
Oh my God.
So you might take a look at that, but it's very well done.
I do want to look at that very much. Maybe I could include it as part of my talk.
Or if you look at the bass line for some of the Doors music, at least,
Bass lines, yeah, it's more common there. And as a soprano, I very rarely sing this, right? So for me, singing the same note over and over again, what is happening? Johnny One Note.
Yeah.
I gotta check that out.
There's also, it's very common to have these presentations where people play as many songs as they can in the same chord sequence, which is usually like G minor C D, right? That's like every song in the world.
Yeah.
So there are a lot of people who do this to figure out how many songs they can play in 5 minutes with the same chord progression.
I think I did see some of those on YouTube, and it is fascinating.
Yeah.
And you realize how repetitive music is.
Yeah.
One question. You want to create music and you want to evaluate it. Have you looked into the research last 6 months on generative adversarial networks? So you have made huge progress in music creation and art creation, and it trains itself repeatedly but you need a lot of data. So if you
Yeah.
get the data.
Okay, adversarial networks. Yeah, I did hear a little bit about some work in them, but is there anything particular you'd like to share? I'd be very interested.
There are lots of things. I could send you some links.
That'd be really great. Certainly anything. It's one of the best things about giving talk. I get to learn. Yeah, absolutely. And we are, one way or another, we're going to get more data. So, and the first thing is run it through some deep learning, let it become more independent, hopefully get more global shapes. Okay, so after putting in self-evaluation, we made another song, and this one I made completely. So this is not a music professor putting it together. And I definitely cannot write songs by myself. This is another Emily Dickinson poem. I usually perform it, but I need a mic for it, and so I made it simpler by bringing in a recording. Music. Okay, well that's, kind of covers the actual lyrical part. But that was fun. I usually perform it with a mic and sing it in the lower register.
So typically, does the instrumental section extend far more than the lyrical component? Or?
So what I do when I produce it is I have the music repeat by itself to kind of show the quality of the music created by the system without the words with it. And I made a few pop songs as well earlier on with the original version of the system, where you also hear the music by itself a little bit. We're playing with different song structures. Actually, right now we're making one that has a lot more words.
So what are the constraints that you actually feed? Do you actually start off with a time signature, or if you're forcing the rhythm, or?
So you're providing the time signature, the key signature, and you're generating it one sentence at a time. You're giving it one sentence of, I did my power in my hands, and then it gives you as many options as you ask for a melody for that one sentence. You pick which one you like, repeat for the next sentence, string them together.
Okay, but given that you picked something earlier, does that affect the choices that?
It could. So there is a way for it to take into account like the last few notes to make the transition more smooth. And Joshua Palkey liked that feature. I usually don't use it. Personal preference. Yeah, it would be nice for it to have more of a global vision for where it's going. A lot of work in, well, not a lot, the few papers that were written about songwriting often tried to do everything and didn't do anything in as much depth, right? And what we wanted to do is to start with a really small task and do it very well, and then zoom out and ideally create a system that does the whole thing independently and does it well. And even within the task of creating one single musical line for one sentence, to do that genuinely well in a way that's genre flexible, very responsive to your input, it's quite challenging, even that little piece. Okay, so I'm going to change gears for a little bit so that there's time to talk about composing lyrics. So, there's a lot of work in natural language generation, and there's actually a lot more work on creating lyrics and creating complete songs in the literature. But the problem with previous lyrics is that they're incoherent often. One of the challenges often with generated systems is having this global structure, and you really see that with lyric generation. So we wanted to create lyrics that are coherent because we wanted to make songs out of them. And
Have you heard recent pop music?
Hmm?
Coherence is, I mean,
optional.
Well,
yeah.
I should really show you. I mean, I should include examples of just how incoherent. It's impressive. You're right. Recent pop music sometimes feels like it's not saying anything coherent, but then you see some of these generated works and, okay, never mind. Pop music could be worse. But that's right. So reaching a point that's comparable to pop music is perhaps easier than trying to match other genres. And so our initial attempt used a system called Mashika, which is a narrative generation system. And it writes write narratives about the Mexicas, which are the indigenous people of Mexico City. This is a system by Rafael Perez by Perez. So we were using an existing system, collaborating with Rafael. And so here's an example of what the system makes. The priest was born under grace of the great God. The lady was an inhabitant of the great city. The lady wanted him from the start. The lady hid her love from the prince, but she fell in love with him. The princess was in love with the priest. The princess admired the lady. So very like bite size. The story is not intended to flow. It's intended to just provide the bare bones for a good story. And this one continues. And so we wanted to take this and somehow convert that into lyrics, resting on Mexica for the coherency. So we ended up creating a system that, first let me show you the result. We fed it through our system, and what it does is it adds a lyrical type line after each line in the narrative in an effort to create lyrics. So the priest was born under grace of the great God, and evolving from the shadows lifted. The lady was an inhabitant of the great city, but just remember there is a sign of intensity. So it kind of takes it out into a slightly more poetic world. And it was very surprising for me that we actually managed to do that it was already somewhat reasonable without altering the original sentences. And of course doing that could only help things further. So the system, this is done, most of the work was done by my student Divya. She kind of came up with this concept. It's a very simple model underneath here. These are Markov chains and trained on a large corpus of pop songs. And so we create many different sentences and then evaluate them based on their fit with a narrative line. So for example, over here, let me see. So we want to find new sentences that have a similar number of syllables to the narrative line and also rhyme with the narrative line to various degrees. So we have various scores for rhyming quality. And the fact that we get imperfect rhymes is actually good, because if you look at pop music, a lot of the rhymes are imperfect. If you make them all perfect, it actually sounds kind of childish. And so that was the original attempt.
It also seems like the story got slightly altered, which is that now it's implying that the priest knows.
That's right.
And it's consistent throughout. So that's interesting. It's very interesting.
It's probably because of the training data. The priest always knows.
That's a pretty strong line.
Yeah,
But she fell in love with him. They don't know the time, wondering where they should have gone. That's right. So the priest is a lot more actively involved now in this whole process, which is amazing, right? So this is actually a phenomenon where us humans have a way of attributing meaning where there isn't necessarily much. I guess in this case, it's very clear. The signal is very, very strong in this case. But even if the signal is weaker, humans are amazing at giving meaning to things, which is okay, because I think pop music relies on that very heavily too.
But the red line is generated one by one from the previous black line.
That's right.
Only the input.
Yes,
right?
that's right. So it's trained on pop music, and then it's selected based on the narrative line. Let me keep track of time since we're getting closer. Okay, I think we're good still. I'm going to try to finish a little early so we have time for just questions. Yeah, so that was really fun. We're going to present it in a couple months. No, less than in a month. That'll be fun.
So it's a character-based Markov chain or word-based Markov chain?
Word-based. Yeah, not that. Yeah, word-based. We're just trying to go for something coherent. Now, to be honest, while I really like this, and I was happy that we were able to get somewhere using fairly simple approaches, things got a lot better once we turned it into co-creative mode. Because my goal, again, is to create something that's useful in the musical realm. So one thing that we're planning to do in the future is to change these, the original system Mexica to work better for pop music. So in particular, notice that these are stories in third person, and most pop music is in first person. So that's actually an important difference. And there are other differences. For example, a lot of Mexica sentences are long, actually, much longer than this. but I would like to shorten some further and change the topic. So there's a lot of stuff that can be done on the narrative writer to make the system create songs that are more in line with the genre. But with the co-creative methodology, we were able to get much faster. So my student and I sat down, and we just created this really simple story by ourselves. A beautiful memory, it was always you, wishing you were back, thinking of only you. Bare bones of a story. Fed just that into the system multiple times, and created a pretty long song out of it. Using the same kind of methodology, pretending that this is our narrative. And actually today, Josh Palti told me, I made up the melody for it, and today he told me he came up with an accompaniment for it. So very soon there is going to be a song from this. I'm very happy about the marriage of my two systems. So here's what we got, I'll just read the first few. A beautiful memory, all my life story, it was always you to make things new. Wishing you were back, but I can't think, thinking of only you, could I make it through? And now we picked, as the next verse, we picked alternative options that the system proposed. A beautiful memory, it could make me crazy. It was always you, try as I do. Wishing you were back, but I can't think, thinking of only you, I was torn in two. Okay, a beautiful memory, we don't need no money. It really took a turn. It was always you, take me to you, wishing you were back, but I can't think, thinking of only you, if I could love you. And that's actually my favorite line, because it could be interpreted in so many different ways. At first I saw it, I don't know how you guys interpret it, but at first I read it as if she's not in love with him, and then somebody else helped me see the opposite. Something very poetic about it. Can go in many different directions. So yeah, soon enough we'll have the full song that combines both systems. Okay, I think we're doing perfect on time. So I'm going to quickly talk about another sub-project, which technically is very similar to Alicia, except we trained Alicia on Puccini music, Giacomo Puccini, one of the best of her writers of all times. Definitely my favorite. And it was challenging. On the technical side, okay, it did not work as well. So that showed us that Puccini music is more complicated than pop. Who would have thought? So that was kind of fun that the machine learning ended up showing that. But nevertheless, so on the technical side, I think there's a lot of work to be done. But nevertheless, we created something out of it. Arido Tarajo, I don't know if I'm pronouncing it right still, created this aria. And this aria is set in World of Warcraft. And the main character, her name is Dahlia, and she's a strong woman, okay? She has some kind of important role in raids, and so her World of Warcraft friends really want her to go on these raids all the time. But she decides to settle down and have a family. You know, create little World of Warcraft creatures. And she's kind of stressed about that now. You know, there is this tension between being an adventurer and being a mother, being part of a family. And we're actually planning a full-blown opera from it. The first one is going to be set in World of Warcraft, and then eventually we'll take it to the live stage and have people perform what a computer created. So this was made by my wonderful, wonderful colleague, James Morgan, also known as Rabayat. And he's an artist, he's a conceptual artist. He's not a musician. As far as I'm aware, he doesn't have any musical training. And he was able to use Roboccini, which is our variation of Alicia, to create what you're about to hear. And that's very impressive to me, that this is useful to an artist who's not a musician. And this was, so he picked out the melodies and strung them together. He also wrote the original lyrics in English, and somebody helped translate them into Italian. And I'm gonna sing it through the speakers. And the machinist is Chantal Gerard, or Harvey. All right, so first, just so you know what you're about to hear, here are the English words. Flash oasis that hides away in caverns, vast open spaces of oranges and gold, the grasses of the prairie, the wandering lizards. So she's describing the scenery. I've made a home and made a family in the south, in an outpost in a small community that sees such traffic in the passing adventurers. And that's where you're suddenly starting to see some of her mixed feelings. And in an expanded version, it's going to go into more detail into some of the struggles that Dahlia is going through. Ready? necessarily, but that's what we were aiming for. All right. There's more songs on my website, myackerman.info, and you've just clicked. So. Yeah.
Have you done a Turing test on this result?
Clarify a little bit.
So like, you know, pick a human and say, listen to this song among some other human-generated song, and say, pick which one is created by machine.
That's right. So Turing tests are a very kind of nice, elegant way of checking the quality of your work through human surveys.
Yeah.
What we have done so far is rank. You know how we have a ranking of our melodies, and we had people evaluate those melodies and see if how they evaluate them aligns with how our system ranks the melodies.
Right.
And there's a relationship that's very, very strong.
Oh, I see.
So the way that Alicia ranks melodies is basically agrees with how humans rank those melodies. So that was great. I'm a little bit hesitant right now to do a complete Turing test, but I think it's definitely down the line because I want to evaluate what the computer does, right?
Oh,
Because there's so much human interaction right now that it would be. I mean, I'm almost certain that I wouldn't be able to tell the difference. Maybe I'm wrong, but I feel like it's a little bit early for that.
Yeah.
But what I would like to do very soon is a study looking at how helpful Alicia is. So having people create songs without Alicia, and then have them create songs
Right.
with Alicia, then gives those songs to brand new people
Right.
and see if they can tell a difference.
Right. So that's process. You want to isolate.
Exactly. But ultimately, once it becomes independent, that would be definitely the gold standard.
Yeah.
Yeah.
And also, I guess the musicians themselves, how they feel with the incorporation of this assistant, whether it actually simplifies their life or just
Makes it
adds some-
annoying.
Yeah, right. Adds unnecessary complexity, really.
Exactly, and so we have a paper, we just got in, where we discuss in detail kind of more of a case study than a large study. Josh discussed his experience.
Right.
And what I'm noticing right now is that when I interact with composers who specialize in coming up with melodies, they don't want this. This just complicates their life, they get annoyed, they feel constrained, which makes sense, right? They're experts, at least is still learning, whereas people who don't specialize in coming up with melodies really like it.
Right.
And I think the better we make it, as it becomes better and better, it can help a larger and larger population.
Right.
But the fact it's already useful for professional musicians, that's pretty cool.
My opinion on the Turing test part also is that it's not necessary for humans to think that it comes from another human being for them to enjoy it, right? It's fine that it comes from a machine. The question is, do I enjoy it? That is really the ultimate test of it.
So that touches on a very interesting point. The human society is very human-centric in many ways, and I don't mean this necessarily as a bad thing, but we like to think that we're special, and that's fine because we are in many ways. We like to kind of downplay the creativity of animals, even to some degree other cultures. Humans really like their in-group in many different ways, and definitely when it comes to anything created by a computer, there's a strong bias. Not as much by a group of people like us, who are in computers, who appreciate computers, but in general, there is this line of thinking within computational creativity that computers can be creative in a different way than us, and that's okay. Taking it a step further, perhaps computers can appreciate things in a different way than us. There's a paper at MMU's Art that had designing music within a computational system so that the computational agents will like it based on their various objective functions, and she didn't even play any music for us. Because it wasn't about us appreciating that music, it was about the computer appreciating its own music. So that's a little bit beyond me, but I was fascinated.
So one thought I had was that, a lot of how music gets created in human society is because of the natural ebb and flow of opinions and likes and dislikes in society.
Yes.
And that tends to be very interactive, right? There's a lot of feedback in the system. So one way you could actually do this is, for instance, you have two systems, Robocini and Alicia, that are both capable of composing music.
Have them work together.
Have them work together.
Yeah, I agree. I think that would be wonderful. And especially putting Mabel into the mix, something that, and Mabel is responsible for a different part of the process, and having them interact by themselves instead of us manually passing the information along the pipeline would be a lot more interesting. Especially if they could give each other feedback. If Mabel could say, I don't really like your suggestion, Alicia. Give me something else. Yeah.
But the difference between these two, Alicia and Robochini, was that just the input? Was it
It was just the input,
input
and
system?
so I'm still happy that we're able to create something pretty nice with it. But if you look at the accuracy of the machine learning models, they plummeted. So clearly there are some other features when it comes to Puccini music that are important that were not as necessary in pop. So we're going to work on improving Robochini until I'm happy with it as a computer scientist as well. Ideally, though, it'd be great to have one system that's genre flexible. But for that, we need a lot more data. Train something like deep neural networks, I think. Then we have a hope of a system that's pretty flexible to genres.
I don't know this field at all, but for me it's kind of a contradiction when you talk about accuracy and when you're trying to measure creativity. It sounds like, I don't know, how...
Oh,
how
no,
can,
you're right. No,
you know, how...
So we're not really... Okay. Yes. So accuracy is an attempt to simulate pop,
right. No, I understand that.
Which is like a smaller scale creativity. I mean, I think if I could come up with songs that would be considered good pop songs, I would consider myself creative. But perhaps we can hold computers to a higher standard, have them come up with their own genres, have them go kind of a little bit further beyond the data that they were trained on. And it's actually not that hard to build in a little bit of that, because you can control the randomness factor with Elysium. And actually, the professional musician who used it, George Pogty, he preferred it to be on the most random. He enjoyed he enjoyed the randomness.
Right.
Yeah, whereas when I use it, I like the more conservative, maybe because I'm not as, I don't know, adventurous as him with my music.
Right. It comes when in the evaluation you have the entropy, and that's kind of related to that, right? That you want.
That's right. So you can see my
randomness,
tendency towards more conventional. Well, I don't know. In a way, these highly repetitive sequences, I think maybe it takes some guts to take a whole bunch of them and call them.
So what are the accuracy metrics that you use? How do you decide?
So primarily we have a holdout set, right? That we are going through that song and asking.
You have a validation.
Exactly, we're asking the system to predict the next note, and if it's exactly perfectly right, that increases the accuracy, and if it's even a little bit off, then that contributes to the error
Okay,
rate.
but mathematically you use just mean squared error, or do you use something else?
Oh, we just calculate the percent of times it hits it correctly. Yeah, very.
So, I mean, the difference between a small note difference and a large note.
No, there's nothing. It's just 0 or 1.
Right.
It's you either hit it, because actually being like half a step off can be a disaster musically. It can like hurt all of our ears.
It could be much worse, be half tone off instead of 1, or an interval, or.
Exactly, but we could in principle punish less for being a third off or a fifth off, because those are more reasonable choices. But I don't know. This is still pretty new work, and I want to be careful not to. There is this tendency when you're creating creative systems to delude yourself into this thing, thinking that your systems are the most amazing thing ever. And so I like using more strict measures to prevent that from happening. So when I see a number 65% accuracy, I know that there's room for improvement. Yeah. And I'm sure if we were to allow fifths and thirds, it would jump up to the 80s and be like, all right, we're good.
Hit just allow anything, and then you've got 100% accuracy rate. Right?
Exactly, it's perfect. Yeah.
So I'm sorry I missed the first part here, it was a bit late, but when it comes to the pop version, you said you could co-create together with a computer, or?
Yes, it's all co-created.
Yeah, it's all co-created.
Yeah, so you give it a sentence of text, and it gives you many different options for melodies, but only for one sentence. And so you got to select and then combine across different sentences.
So if I were amateur, I can use Alicia to help me to compose, and then the more I use it, I become more kind of rely on it, so I won't be better on doing it myself.
That's actually a very good question, and kind of gets us into a totally different direction. I noticed from using Elysium that I now know what I want much more often. Sometimes, whereas in the beginning I had no clue. I would just listen to it and be like, wow, everything sounds great. This sounds like music. So I could play for you later some of the pop songs that are on my website. They're really not as good because I didn't know what I was doing as well. But now I feel like I have some preferences. Like, well, I want the shape to go up and then down, and sometimes I feel like I actually want to go in and change stuff manually, which I don't. it. But I think it actually can be used, and it has been suggested by musicians as well, this could be used as a training tool for musicians to eventually gain independence. It might have to be designed a little differently to kind of force independence later on. But that's a whole other line of work, right? Using this to help learn to compose.
Somewhat of a filter bubble, I suppose. If you just rely on this, and this is the entire universe that I know of, I'm just never going to break away from that. Because that's.
So there's a little bit of both, right? I think perhaps this generalizes. When you're learning anything, at first it's good to be in a constrained environment, like processing in Java, right? Processing is this package for Java that makes it easy for artists to learn how to code. But then after a while, it becomes more constraining than anything else. So it's good to move to the standard Java interfaces. So I think this could be a similar, like training wheels, basically.
Right.
But I don't know. Maybe because I work on it as a researcher as well, I'm less inclined to try to compose by myself. But I'll do this. After today's talk, I'm going to try to compose something by myself. Because I have one song. I only ever composed one song about a year before we made this, and it was awful, and I never showed it to anybody. But I could try to compose something now and see the difference.
Right, then you can see whether that helped you or constrained you and become more reliant on the
Yeah. Well, one thing is, it's known that novices tend to be a lot more conservative than experts. So I remember myself beforehand as an incredibly novice melody writer, unbelievably novice, and all I could come up with were things that were very, very repetitive, very small gaps between notes, so very small intervals, and it all sounded like some kind of folk songs from my childhood. That's pretty much the only place where my head would go. Whereas Alicia gave me a bigger space. Perhaps it doesn't give a bigger space to professional composers, but for me it does. And maybe I could outgrow Alicia. That's kind of an inspiring thought, to be honest.
Question. I have no background in music, but I've heard a lot of time, like not willingly, artists tend to copy other melodies. Is the machine at risk to do the same thing?
Oh, definitely. Yeah, that's right. So one thing that we could do, which we haven't done yet, is actually take the distance between what it creates and the closest thing in the corpus, right? And that way we are, especially as it learns to create longer and longer melodies, or we could do that for the hook to make sure that the main part of the song is not stolen or almost stolen. Yeah, that's right. Especially if you set the randomness factor to be very low, then it can happen. It can happen. Especially once we trained it, just out of curiosity, we trained it on a really small number of songs, and it was creating beautiful music, but it was only a small variation of one of the songs. Yeah, so with a bigger corpus, we're a little bit safer, just statistically, but we could take precaution against that, which would be harder to do for a human musician.
Do you feedback its own compositions as part of the data set that it uses?
We could, but we don't. Yeah, that comes up over and over again. I would like to do that. We have, really, I mean, this could be like, we have like 10 people working on this, and still making a lot of progress for a long period of time. But yeah, that's definitely a good idea, and it's on our to-do list.
I have a question about the poem that you showed earlier. I forgot the whole thing. Like I think of you, whatever that is. And the second paragraph, the second line on the second paragraph, but I can't think. That seems to be the line that never changed for all these. Is that the preference of the?
Oh yeah, that is true.
Yeah. How come you change all the other lines but not that line? But I can't think that line.
I think we didn't have a lot of good options. It's not very complicated. I actually
only that line.
I might actually manually change it, which I tried not to do. But there's another poetry system I've been using called TryPoMe, where you're allowed to make manual changes. I might make one manual change and change this to stop, get rid of the period, and then this becomes like one sentence.
Yeah, just that
Stop.
line.
Yeah, there weren't a lot of good options, and it made me feel like we need a bigger corpus, even though the corpus is already quite large. So I asked Divya to retrain it on a bigger corpus. Yeah, so current research. Yeah, this part has not been published about the co-creative variation. Yeah. Good observation.
Yeah, how come it knows that the machine knows that? I want to keep that line.
Yeah, so this was co-creative. So it actually gave us several options, and we selected amongst them. We gave ourselves. It's kind of fun to play both extremes. Sometimes to not touch anything, let the machine do everything by itself, and sometimes interact with it. I've just done some recent work. I mean, this talk was an hour, so I didn't bring in too much stuff. We've made some stuff with a different co-creative system for making poems, but that one is very heavily co-creative. You can edit and re-edit and regenerate lines over and over again. I changed parts of them, but still my students and I created something really beautiful that I don't think we could have done without it.
Do you think this would be a suitable tool for students, like, I don't know, kids between 8 to 12, maybe, K-12 type?
I would love to explore that, very much so, especially this one. This one's very accessible because music actually the way that we have it designed is pretty accessible as well. But definitely language is, I'm really interested in the co-creative side of it, kind of an HCI perspective, I guess. And yeah, looking at kids would be really great.
I guess the more important question then would be, how do you think the parents would feel about robots teaching their children
I would be happy to let my son try it, because you never know those kids. My son is 17, and I know he always sit with friends, his friends who like music, and they created their own, and some sound like, not composed by them, but some software that they
Right.
collaborate together and make. He said sometimes he just makes some sounds and then put into that different sounds, different artificial sounds, and put in that music. And I said, oh, that sounds great. But they said, all we did was this and that and boom, 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 and then they got some.
They filter it.
Yeah.
Yeah.
And that looks really cool, and they're very creative.
Yeah, no, that's very true. I was invited to do a week-long seminar in Mexico to fairly young students, well, perhaps like late teens, early 20s, and I was going to center it on using these systems and see what they can create co-creatively. So that's going to be our pre-experiment, and eventually be great to do a formal experiment for sure. Yeah.
So how important do you think is the size of the data set?
Oh, extremely.
Can you just set some rules and then can the machine generate based on rule base?
Oh, of course, and most systems are like that. For these two domains, for lyrics generation and for melody generation, they're almost all rule-based generation. I don't like it. It's just so restricted and so constrained. It has no room for growth. So I kind of commit myself to having at least a major component that's state-driven.
All right. Let's thank our speaker. And for those of you who have feedback, I know there's a lot of good things.